Hello, this is Nick Andre, your at-home instructor, welcoming you to another videocast. In this videocast, we will review what have we learned thus far in this course to prepare you for your first exam. Your first exam will consist of two parts, a section on computer theory worth 70 points and a hands-on section worth 30 points. Both sections will be administered through Blackboard. Be sure to check our course management system to see when the assessments will be available. The theory section will consist of 20 multiple choice questions, a few completions, and a couple of short answers. A practice exam has been posted on Blackboard for you. This fake exam was designed to illustrate what your actual exam will be like. I would recommend taking it. Of course, this practice exam does not count against you. The hands-on section consists of a few important word processing topics like formatting text, inserting clip art, modifying a page layout, dealing with tables, and changing the document's header and footer. I will treat this section of the exam as if it was a lab assignment with one exception. You will only have 24 hours to complete this part and submit it. Just like the theory section, this part will be managed by Blackboard. One of the very first topics we have learned dealt with file management. We shortly learned what the difference between a file and folder was. A folder organizes files, and files contain data. Once we discovered that a file contains data, and data was stored in a binary format, we shortly learned that the operating system used the file extension to determine how to display those zeros and ones. Some classic or common file extensions are as follows. Word, which uses DOC or DOCX, Excel's infamous XLS or XLSX, and PowerPoint's PPT or PPTX. Generic file types include JPEGs, which are used to represent photos, MP3s for music, and AVIs for movies. Of course, these generic file types are not limited to just these examples. I often ask my students, what happens when you delete a file from your flash drive? Does it end up in the recycle bin? What good would the recycling bin if it didn't end up there? Unfortunately, a file deleted from a flash drive does not end up in the recycle bin. Remember, your flash drive is portable and limit on space. Since these drives are portable, what recycle bin would the file appear in? When you delete it, would it appear in the public computer where the file was deleted on, or on your home computer that knows nothing of the deletion? Another tricky question, what is bigger, a megabyte or 1,000 kilobytes? Neither. They are roughly the same. It's probably a good idea to know your units of storage, bits, bytes, kilo, mega, giga, and tera, before taking the exam. Before concluding the section on file management, watch this video. In the video, what key did the user hold down while selecting non-adjacent files? If you answered Control, then you'd be correct. When it comes to file management, I love using the Control key to randomly select files scattered in a folder, or the Shift key to select a continuous list of files. Alright, on to some number theory. On the exam, I will ask you to count in some foreign number system. In this example, I'm going to count to 15 using base 6 as my number system. Remember the rules of counting. First, establish your base. Our base will consist of 6 numbers, from 0 to 5. Once you have established this base, we must use each symbol only once. That is 0, 1, 2, 3, 4, 5. When you reach the end of the base and all possible combinations have been used, create a new place and start over. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 0, 2, 1, 2, 2, and 2, 3. See if you can apply these rules and count from 0 to 10 in binary. Remember, binary only consists of two values, 0 or 1. Now might be a good time to pause this video. Welcome back. Let's see how well you did. The first two should be easy. 0 in binary is 0 and 1 in binary is 1. A 2 would be a 1 followed by a 0. 3 is a 1 followed by another 1. 4 is a 1 followed by 2 zeros. 5 is a 1 followed by a 0, then a 1. 6 is 2 1s followed by a 0. 7 in binary is simply 3 1s. 8 is a 1 followed by 3 zeros. A 9 is a 1, 2 zeros, and a 1 again. And finally, a 10 is 2 sets of 1s, zeros. Before reviewing digital representation, I want to go over number conversion. More importantly, I want to talk about binary to decimal conversion. Remember in class, I showed you how to divide a decimal number by 2 to get its binary equivalency. Now let me demonstrate how to take a binary number and convert it back to decimal. Step 1. Take your binary number and break it down so each bit is placed in its appropriate place values. Before doing this, I like to create a place holding table. A binary place holding table consists of a 1 in the first column, a 2 in the second column, a 4 in the third column. I will keep doubling this number as I move from the right to the left until I have enough places to hold my binary number. Step 2. Now that my table is created, I will place enough bits in its appropriate places. That is to say, this 0 belongs to the 1s column. This 0 belongs to the 2s column. This 1 to the 4s column. And this 1 to the 8s column. I will continue to do this until all bits have been placed. Step 3. To convert, I will multiply the place values with the bit underneath and then add these decimal numbers together. So 1 times 64 gives me a 64. Times a 1 yields 32. 0 times anything will always be a 0. 8 times 1 gives me an 8. 4 times 1 equals 4. The other two produce zeros because 0 times anything is 0. Now I'll add 64, 32, 8, and 4 to get an answer of 108. In one of our lectures, I used an index card and an ASCII table to demonstrate how computers store character data. The table consists of our American symbols, which we call letters, their decimal equivalents, and their decimal equivalent. I also mentioned as computers are becoming more and more powerful, so has our encoding tables. Today's computers are using Unicode, which is big enough to store all symbols, both past and present, as well as all future symbols known to mankind. In this discussion, I asked, what is digitalization? As we shortly found out, digitalization is the ability to represent different type of information using a binary format. Of course, one could now ask what the difference between digital and analog is. Analog covers all degrees of quality. Unfortunately, the quality degrades and is hard to reproduce precisely each time. Digital is simple and discrete. This is why computers use the binary number system to represent digital data. Because of binary simple nature, it is easy to reproduce digital data with accuracy each time. Unfortunately, in order to compete with analog, digital requires a lot of bits. In fact, digital requires 24 bits to represent one dot of color, or pixel. Since digital requires a lot of bits to store information, it also requires hardware to process the data back into information. The CPU uses the control unit to fetch the data and the instructions on how to process it back into information from memory. Once the data arrives from RAM, the control unit can inform the ALU how to manipulate the data back into useful information. This information is then stored in memory. This process of fetching, decoding, executing, and storing happens all the same in the machine we call computers. As a result, we give it a special name. In computer science, this cycle is known as the machine cycle. By definition, a computer is a device that can allow a user to input data to be processed and sent out as information. Some common input devices are keyboards and mice. The central processing unit, memory, and storage components contribute to the P in IPO. And some common output devices would be your monitor, printer, or speakers. How fast the machine can fetch, decode, process, and store information depends on a number of factors, such as the amount of memory the computer has at its disposal. The more memory it has, the less trips it must make to a slower secondary storage device, like a hard drive. Of course, the quicker they can crunch out the information, the faster the machine will be. Clock speed and word length go hand in hand. Recall the difference between a sports car and a bus. The sports car can travel faster, but only holds 2 passengers. The bus, on the other hand, travels slower, but can handle more passengers. So the greater the clock speed and the larger the word length, the better the performance. A side note, the word length also determines the amount of memory a computer can have. When explaining how dual-core or quad-core processors can improve a system's performance, I use the example of doing laundry. Doing laundry consists of 4 separate tasks called threads. If you had more than one washer and dryer, then multiple loads can be executed at the same time. Multiple core processors allows users to run multiple programs at the same time without affecting the computer's performance. Other factors of performance include transfer rate and instruction sets. Transfer rates measure how fast the data can get from secondary storage to memory, from memory to cache, and back again. It's also known as bandwidth. Ultimately, when we shop for a computer, performance plays a big role. We typically want the most bang for our buck. However, we need to keep in mind that we can extend the life of our existing computers by simply upgrading them. Ports and expansion slots play an important role during this process. The speed in which ports can transfer data can determine the types of devices I can add to my machine and thereby continuing its usefulness. A port I would like to bring to your attention, not listed on the slide, is the Thunderbolt port, as I believe it'll offer end users the ability to upgrade their computer's memory, processor, and other devices without ever opening their computer's case. To add additional ports, or ports that your computer is currently lacking, you can buy an expansion card, USB hubs, FireWire, or Thunderbolt hubs, and if your laptop supports it, a docking station. Remember, ports give the user the ability to add additional devices to their machine, giving the computer another purpose. These peripheral devices could be a digital camera, scanner, or printer. An integrated circuit is a bunch of transistors, resistors, and capacitors joined together to store, process, or represent information. Examples of integrated circuits include processors, memory, and flash drives. The main component of integrated circuits are the transistors. In principle, the transistor gives the computer its power. Gordon Moore, an engineer and co-founder of Intel, stated that every 18 months, computer power will double. That is because The smaller and smaller Intel has been able to make transistors, the more and more they can fit on a processor, making it even more powerful. Pun intended. Since transistors act as tiny switches that churn electricity on and off to represent binary values, and RAM is made up of transistors, it's safe to assume that RAM needs electricity to store data. Because RAM depends on electricity, when the power goes out, the data disappears, hence making it a volatile storage device. To prevent data from disappearing, more permanent devices such as hard drives and flash drives, as well as optical drives, exist. A hard drive has moving parts and uses magnets to store data. As a result, these drives tend to be slower and have a higher failure rate. On the other hand, solid-state drives use circuits to store data. These drives have a much higher transfer rate and high-level durability. I would personally recommend this drive for laptop users, as they are really fast, use little energy, and can take a beating. However, they are a little expensive. Although they are testable, I believe optical drives like CDs, DVDs, and Blu-rays are on their way out. Flash drives and the ability to store information on the cloud will likely replace these devices. But until that day comes, you will need to know these devices for your exam. I included this slide to give you a heads up that just knowing how to accomplish something in Word will not be enough for this exam. You will be asked a few questions on this exam about Microsoft Word. An example of such a question would be, in Word, what happens when text is dragged to a new location in the document? Of course, the text is moved to this new location. Another question, not on the slide, but might be on your exam, would be the name of the blinking cursor on the document that inserts text. I'll let you find that one on your own. Some questions on your exam may be true and false, like this one. In Word, an entire column from a table can be deleted by selecting it and pressing the delete key on your keyboard. Unfortunately, doing this will only delete the contents of the column and not the column itself. We have reached the end of your review. Remember to take the practice exam, check Blackboard to see when your first exam will be. This has been your at-home instructor, and I will see you in the next videocast.